Welcome back. Today, guys, we are going to start learning the language of chemistry. Now, remember, there's two things that I really told you that you need to know to be able to do. The first one was factor labeling or dimensional analysis. Okay, but before you can even start getting into doing the dimensional analysis, you need to be able to speak the language of chemistry. Think back to the previous science classes you've taken. Science is vocabulary rich, meaning there's a lot of words. You probably learn more new words in your science class than you do in your foreign language. So today we're going to start learning how to speak chemistry. Okay, you guys probably already know this. You already know some of the language of chemistry, but I'm going to break it down and teach you basically how to do it, how to speak chemistry. So let's go ahead and get started. Okay, so can you speak the language of chemistry? What you need to be able to do is become fluent in this language. Okay, you're already fluent in English. For example, in English, when we say a word, we get an image. So if I say the word cat, I'm going to get an image of a cat. Hopefully your cat looks a little better than this. Now in chemistry, okay, when I say sodium chloride, I need to think NaCl. Okay, that's its chemical formula. And that's what we're talking about, learning to speak the language of chemistry. You need to be able to think and write these chemical formulas. Okay, so let's talk about the language of chemistry. Well, like all language, chemistry starts with this alphabet, and you already learned a lot of the alphabet. That's our chemical symbols, our elements. Okay, remember, you're going to need to learn 62 of those for this class. That you're going to have memorize the name and the symbol. Okay, the rest of them you can look up. Now, what do we do once we have the letters? Well, we put them together to form words. And then the words in chemistry are what we call compounds. And compounds are pure substances made up of two or more elements that are chemically combined. So they're two or more elements that are stuck together to form one single substance. And well, what do we do once we have words? Well, we put them together to write sentences. And the sentence in chemistry are chemical equations or reactions. And we're not really going to get into those much until second semester, because you really have to get down writing these compounds first before you can move into chemical equations. Okay, here's an example of a chemical equation. This is the one for photosynthesis. Carbon dioxide plus water plus energy, which is sunlight, gives us glucose, that's C6H12O6, plus oxygen. That's our sentences that we're working up. Then once we get up to sentences, then we can go back and apply the factor labeling to them. Alright, so once we get these compound forms, we need the way to write the words out, and that becomes a chemical formula. Chemical formula is simply a representation of the composition of a substance using chemical symbols and numerical subscripts. For example, H2O for water, NaCl for sodium, CH4 for methane. You've seen these already, okay? You know what these are, but you just want to give them their correct name. Now, we said subscripts. Subscripts are the numbers that we find beneath the chemical symbol or the element that tells you the number of atoms of that element present in a given compound. So if we look up here, we see that in water there's 2 hydrogens. In methane there's 4 hydrogens. Okay. Now sodium chloride, they don't have any subscripts. Okay, but they are written, so we assume they have a subscript of 1. Okay, if it's just 1, we don't write it. Okay, and this is what your goal today is to learn to start writing these chemical formulas. First thing we have to look at, though, is something we call intramolecular forces. I want you to underline the word intra in your notes, because later on we're going to talk about intermolecular forces, and you need to keep the two separate. But for right now, we're talking about intra. And intra means within. So the intramolecular forces are the forces that hold atoms together to form these compounds. Okay, we also hear them referred to as chemical bonds. Okay, so intramolecular forces hold compounds together. Now, if we look at pure substances, there's 2 basic types of pure substances. One we've already learned about; those are elements. Okay, and the new one that we're starting to learn about is compounds. For example, sodium chloride here, or glucose. Okay. Now, under compounds, there's 2 types of compounds, and the difference called salts and molecules. And the difference between these two is how the atoms are held together. Now, salts, guys, don't think of it just as NaCl. Okay, salts is a generic term, so don't think every time you hear salt, think table salt. No, salt's a generic term. A salt is a compound that results from the attraction of oppositely charged particles, or ions. Okay, a positive ion plus a negative ion. Opposites attract, right? They come together. So that's what forms a salt. Molecules, on the other hand, results from the sharing of electrons, we call these the sharing covalent bonds. So two types of intermolecular forces that we're interested in are ionic bonds and covalent bonds. The covalent bonds, I call those my kindergarten or my Barney bonds, right? Sharing is caring, Barney taught us, okay? The ionic bonds are more like high school bonds, where you just steal from each other without really asking. So remember, if you're sharing with somebody, you're probably going to have a stronger bond than if you're just stealing, okay? You're not going to like that person as well if they're stealing from you. You're probably not going to have as strong as bond, okay? So covalents are usually a little stronger than salts are. Okay, let's look at salts. For an example here, sodium. If we look at sodium, it's in column 1, so it has 1 valence electron, and chlorine, which is in column 7, so it has 7 valence electrons. Okay, when these form ions, what's going to happen is the sodium, it's easier to lose that 1 than to gain 7. Okay, so it's going to lose that 1, and chlorine, it's easier to gain 1 than lose 7. So it's going to transfer the electron from sodium over to chlorine. So sodium becomes a +1 because it has more protons and electrons. Chlorine gained an electron becomes -1. Okay, so we write these. The chemical formula for sodium chloride is NaCl. Let's look at molecules. Example: 2 chlorine atoms coming together. Remember, both of them have 7. Okay, so what's going to happen in this case? They are going to come together and share a pair. Okay, when they share a pair, what we see is this chlorine molecule has 2, 4, 6, 8 electrons. Think it's happy. This one then has 2, 4, 6, 8. It's happy. Both of them think they have a complete set of valence electrons. They're happy. It's a really strong bond. This is chlorine gas. Okay, maybe you've heard of it. Very deadly. So how do I know if something's going to be an ionic bond or covalent bond? Well, it depends on where the atoms come from. What groups in the periodic table do they come from? So ionic compounds are going to be between a metal on the left-hand side and a non-metal on the right-hand side. When I say right-hand side, I'm talking of that metalloid, that diagonal line. Okay, and what we're going to start talking about today is binary ionic compound. Binary, bi means 2, so these are going to be ionic compounds made up of 2 elements. So a binary ion consists of a metal or hydrogen. We're going to consider hydrogen to be a metal in this case, or it's going to be positive, plus a non-metal. So our metals are cations, or positively charged. Our non-metals are anions because they gain electrons. They're going to be negatively charged. Now, covalent compounds, they're going to consist of 2 or more non-metals stuck together. So both elements, or all elements, are going to come from the right-hand side of the stair steps in the periodic table. So if it's 2 elements, they come from opposite side, they're going to be a binary ionic compound. If it's 2 or more and they all come from the right-hand side of the periodic table, they're going to be a covalent. So just looking at where the elements are found in the periodic table is going to let us know what they are. Okay, so let's talk about writing chemical formulas for ionic compounds, for binary. And the other ones for ionic types of ionic will follow this as well. So the goal of writing these compounds is to have both the positive and the negative charges balance each other out, meaning the overall charge of that compound is going to be 0 when the charges are added up. Let's see what I mean here. So NaCl, we just looked at this one. We said sodium forms a +1 charge. Chlorine forms a -1, +1 plus -1. Overall, we have a negative charge. How about this one? Lithium oxide. Lithium is a +1. There's 2 of them, right? We got 2 of them here, so we have a +2 charge. Oxygen, if we look on a periodic table, has a -2, so +2 plus -2 is 0. Okay. Well, we could go through and figure them out that way, but there's an easier way we have rather than writing charts out like this, and we call that the crisscross method. Okay. 2 basic things you need to do. First thing you need to do is write down each element as its ion, showing its charge. Okay, so for magnesium and chloride, magnesium has a +2 charge, chlorine has a -1. Then what we're going to do is we're going to draw what we call these crisscross arrows. Okay, the crisscross arrows tell me where I'm going to move my charges to, or the numerical value of my charge. So I'm going to take this 2, put it down here with chlorine, My 1 from chlorine is going to come down to magnesium. I'm not going to worry about these charges once I move them. So my chemical formula for magnesium chloride is MgCl. We rewrite the ions as compounds with the correct subscript. So the +2 for magnesium came down here. The -1 from chlorine came down here. Well, why didn't I write it? Well, if it's a 1, like we said earlier, we don't write it. So let's check ourselves on this. Magnesium has a +2 charge. We have 1 of those. Okay, so it's going to be 2. Chlorine has a -1. Okay, we have 2 of those. 2 plus -2 is 0. Pretty simple. Okay, let's try another example here. Aluminum and sulfur. First thing we want to do is write down their charges. Aluminum is +3. Sulfur is -2. Now you can write them that way. I like to write them sideways like this. Now do your crisscross. Okay, rewrite it as a compound with your chart. The numerical value charges becoming your subscripts. So it becomes Al2S3. We could check it. Okay, we know we got 2 aluminums here. They're +3 each, so that's 6. We got 3 sulfurs. 2 times 3 is -6, so +6 plus -6 is 0. Really simple. Here's what I'd like you to do. Write these down, pause them, go ahead and solve these on your own. Give me the chemical formula for each of these, and come back and check your work. Alright, let's see how you did. First thing we need to do is write the charges. Calcium +2, sulfur -2. We do the crisscrossing, and we get Ca2S2. Notice here how both the subscripts are the same. We're not going to leave it like this. We always want to be in the lowest ratio, okay? So what we're going to do, since they're both 2 and 2, we divide each of these numbers by 2 and get Ca2S2. Let's say it was 3 and 3, for example. Well, we divide them and we get 1 and 1. Okay, so you always want the lowest whole number ratio. How about the next one? Fr is +1, O is -2, crisscross, Fr2O. Next one. K is +1, F's -1, we get Kf. Okay, remember, we don't have to write the number 1 if it's there. Okay, last one you should have got because it was our example from that aluminum salt from a previous. Excuse me. So Al2S3. So this is pretty simple writing these binary ionic compounds. Write them out like this. Draw your crisscross arrows. I didn't put them in here, but you should draw them on your chart just to remind you. Remember, we don't write any charges down here. Just the numerical value drops down. Okay, now that we know how to write the compounds, we need to know how to say them. We know that NaCl, for example, is sodium chloride. How do we know this? Well, the name consists of a binary ionic compound. Remember, I'm stressing binary, made up of only 2 elements that are going to be a cation plus an anion. Consists of 2 things. The first thing it's the name of the cation. That's the first element without the word ion. So basically, it's just the name of the first element. Okay, and then what we do is we put the name of the anion. Remember, anions end in IDE: chloride, fluoride, oxide, nitride. Okay, so the name of the cation without the word element. So name of the first element plus the name of the anion. Let's look at a couple examples here. NaCl, sodium chloride. HCl, hydrogen chloride. Okay, so pretty simple, guys. It seems simple, but this is one of the most important things that you have to be able to do this semester. If you cannot write binary ionic compounds, from here out, everything's going to be difficult, because this is the first thing you have to do, is be able to speak this language of chemistry. And it's only going to get a little harder. We're going to add what we call polyatomic ions and variable charged ions with the salts. And then we're also going to learn to do molecules, 2 types: regular binary covalents, and then also organic ones. So look this over, guys. Be able to do these problems. If you have any questions, come see me. Let's get you ready to go on this. Until class, guys, take care. We'll talk to you soon.